Today I'm joined by Mike Rosenstrike, the Managing Director of Hexagone Resources. Mike, thank you for your time.
My pleasure.
Mike, Hexagone has made a very significant announcement covering two key areas around test work and downstream processing. Could we begin with you providing a bit of an overview of the announcement?
Look, it is quite a detailed technical announcement, so it's a great opportunity to perhaps just put a bit of colour around the key things. The announcement really covers two main aspects. One is how we're planning to modify the overall flow sheet of our material. You'll recall that we had announcements that talked about purity, so we've made a reconfiguration of the flow sheet that does purification first. Purity of the graphite material is a key value driver. The second aspect of the announcement deals with one of the downstream processes, which is called spheroidization. Spheroidization is when you take the graphite flakes and you mill them and shape them into material that's suitable for lithium-ion batteries. So those are the two issues that the announcement deals with, and it's really part of our overall rollout of our product development and marketing strategy, and I think you'll find there'll be a lot of these kind of announcements coming up.
So let's go into a little bit more detail, firstly around your graphite processing strategy.
Sure. The key differentiating feature of our graphite material from the Macintosh project is the ease with which we're able to purify it to very high levels. We're able to attain, using a furnace technology, 5 nines purity, 99.999% total graphitic carbon, at using environmentally friendly and cost-effective means. Costs for that are comparable or lower by our estimates of what's currently occurring in China, where perhaps they don't have the same sort of environmental constraints. That ease of purification, that low cost, that creates the opportunity for us to move purification from the end of the flow sheet to the very start of the flow sheet, so that we plan to purify all of our concentrate feed. Remember, purity is a key value driver for our material. So in terms of downstream processing, if we're purifying everything first and then using that ultra-high purity material as a feedstock, there is no waste. We plan to use every particle of our concentrate through our process flow sheet to create a range of high purity, high value products. No product and waste or lower grade material.
Okay, moving on to the battery test work, what are the key findings?
The key finding is that we're able to generate a yield of 100%. That means that almost 100% of the feedstock into a spheroidizing unit will come out as high value premium end materials. The comparison to that is perhaps the more traditional flow sheets, such as employed in China, and China dominates this industry, where probably you're getting yields of around 18 to 50% to a high value spherical product, and the balance, whether it's 70 or 50%, is going into, I wouldn't say waste, but a lower value material. So their yield is, say, 50% to the desirable product. Our yield, I would argue, is 100% into several high value product streams. And what I mean by those two product streams is that we've got 70% yield going into anode material or spherical graphite suitable for the anode side of lithium-ion batteries, and we've got about a 30% yield going into what we've grouped as a conductivity enhancement material. Now that material can go into a range of battery chemistries, and generally it actually gets higher prices in that purity level than you get for the anode material. So that's why we talk about 100% product yield. And there's another aspect around the spheroidization test work that we've reported on, and that is that we're not using the traditional cascading impact mill setup, which again is very prevalent in China and is being used by other emerging downstream processing operations offshore. We're looking at using a singular stage milling setup. It's technology that originates from Japan, and what that offers us is a simpler flow sheet in terms of the spheroidization, at lower cost and at higher efficiency.
So Mike, what does all this mean in terms of stage 2 of the Macintosh project?
Well, for context, let's remember that stage 1 is all about the Macintosh project. It's where we have the 51-49% joint venture arrangement with Mineral Resources, who are effectively fully funding and managing that project to ultimately deliver graphite concentrates. So stage 2 is all about downstream processing, and that's 100% Hexagone. And we're working with our US-based partner to look at exactly what opportunities in terms of product development we can explore. So what's coming up on the horizon in the near term is we have some further battery-related test work to come out, and I hope to be able to report on that over the course of the next few weeks. But at the same time, we're also looking to establish our purification technology by setting up a pilot plant that we're able to demonstrate to potential customers exactly what samples of Macintosh graphite that have been purified look like. So it's sort of a moving forward in the feasibility with a pilot plant, and then moving that into a marketing aspect as well in terms of product offtake. We aim to have that pilot furnace facility well advanced late this year, early next year.
You specifically highlight in the ASX report that batteries are just one part of your overall product development strategy. Can you expand what that means?
Batteries and anode material for lithium-ion batteries is really very topical at this moment, and we're absolutely part of that, and pleased to be so. But people need to understand that the lithium-ion battery anode industry is absolutely dominated by China. So the key in terms of our business development strategy is we want to draw the most value out of the material that we can, and that higher value isn't necessarily in the anode space. And because of that dominance, we want diversification. So if I look at our product mix that we're planning to produce, I would break that down to be roughly 1/3 battery material. That's both anode and cathode material. I'd say it's 1/3 expandable graphite. That's the material that goes into shielding and foils. And we're in the our purity level enables us to get into the purity required in the nuclear industry. And then the final third will broadly go into traditional industrial uses, but that demand very high purity levels, such as refractories. And this is the opportunity for us to look at displacing synthetic graphite. And an obvious large-scale market that we've identified is displacing synthetic graphite utilisation in the manufacturing of electrodes that are used in the electric arc furnace industry. That's a 750,000 tonne a year scale market. In terms of our recent announcement, I'd suggest that battery anode material is probably our lowest value product. I talked about diversification earlier in terms of our 3 main product groupings, but even under battery materials, we have diversity in terms of material, about 70% going into the anode side as spherical graphite, and 30% potentially going into what we've called conductivity enhancement material. And so we've got a diversity of products there, and that's how we get that overall 100% yield, and we're not wasting a single flake of graphite, because underpinning all of that is a 99.999% purity level.
Mike, anything else you'd like to add before we wrap up?
Look, I'd just like to acknowledge the support of all of the people that invested in our recent $7 million placement, and in particular the Tribeca Natural Resources Fund and Mineral Resources. It's a positive sign. The placement was heavily oversubscribed, and we're really appreciative of that support from them. The purpose of those funds is exactly to undertake this downstream processing feasibility study test work. And I look forward to sitting down with you and having more discussions where I try and unpick the technical detail that's within the announcements that we're making.
Mike, thank you for your time.
My pleasure, David. Thank you.